All right, let's dive right into this explainer because today we're unpacking something literally mind-bending. We're looking at a fascinating framework that completely shatters our traditional understanding of space, time, and, well, the Big Bang itself. If you've ever tried to wrap your head around cosmic inflation, or dark energy, or the ever-expanding fabric of the universe, what we're about to explore offers a radically different and honestly incredibly elegant alternative. It's called the Big Circle Theory, and it asks us to view the entire cosmos not as a physical void stretching out, but as pure, unadulterated information. The source text actually hits us with this profound question right out of the gate. Did time always exist? It really forces us to stop and ask, what was there before the universe even began? Under standard relativity, space and time are this one woven fabric, space-time, and the Big Bang is the starting gun for both. So asking what came before is usually brushed off as a nonsensical question, but this paper, it proposes something entirely different. It asks, what if time isn't a fundamental dimension at all? What if actually it's just an illusion? To unlearn decades of standard cosmology, we're going to follow a pretty straightforward roadmap today. First, we'll go beyond the Big Bang. Then we'll look at the universe as information. Third, we'll unpack the Big Circle Theory itself. And finally, we'll see how this applies to solving cosmic mysteries. So starting with part one, beyond the Big Bang, rethinking the origins of everything. We have to begin by questioning the standard model of the universe. You know the one. It relies on a massive primordial explosion from a single infinitely dense point, followed by an ever-expanding fabric of space. Typically, this standard model, often called lambda CDM, requires expanding space, a mysterious repulsive force we call dark energy, and that famous Big Bang singularity. But this new framework, the TI-squared model, trades all of that in for static space. In this view, the expansion we think we're observing isn't actually space stretching out at all. It's simply informational entropy shifting around in these continuous, infinite cycles. Moving right into part two, the universe as information. We're looking at space, time, and data congestion. Okay, so this right here is the absolute core of the T-squared theory. T-squared stands for the information of information theory. It basically argues that the universe is not a physical void, but rather this intricate, buzzing web of data exchanges built on three interdependent states. They call this the triad of information. First up, we have information presence. This gives systems their stability and continuity. It's actually the origin of what we feel as inertia and gravity. Second is information interaction, which handles the local, day-to-day exchanges that we perceive as physical forces. And third, information resonance. This one is wild. It's a global, instantaneous coherence that allows the entire universe to transition phases all together. And remember, these aren't separate compartments. They're all happening at the exact same time. So, the absolutely crucial point here is how this affects our whole concept of physical matter. In this model, mass doesn't really exist. Instead, what we have is informational density, which means gravity is no longer some fundamental force bending the fabric of space. It's merely an emergent illusion created by highly congested areas of data. It is, quite literally, a cosmic traffic jam of information exchanges. And because gravity is just a data traffic jam, time gets a complete redefinition too. If nothing interacts, time simply does not exist. Time is not a fourth dimension like we've been taught, it's just a measure of interaction rates. So in areas of extreme data density, what we would normally call high gravity, the processing slows down. It just takes longer for the data to exchange, creating what we perceive as time dilation. Basically, time runs much slower where information is super congested, and it zips by faster in the empty, quiet voids of space. Now, you might be wondering, how does this deal with the speed of light? Well, the author uses this fantastic ocean analogy. The speed of light, our ultimate cosmic speed limit, is just the speed of the waves traveling across the water. It limits local cause and effect. But that informational resonance we talked about earlier, that's like the tide rising everywhere at once. The universe updates its global state instantaneously without ever violating the local speed limit of those waves. All right, section 3, the Big Circle Theory. We're diving into infinite cycles of matter and antimatter. With the fundamental rules of reality totally rewritten, we can now zoom out to the macro-level structure this creates. Instead of a linear timeline that starts from a singularity and ends in some cold, dark, depressing void, the universe cycles continuously through 4 distinct quadrants. It cleanly alternates between phases of matter and antimatter. Quadrant 1 is matter, quadrant 2 is antimatter, and so on. It is a perpetual, infinite cycle of cosmic reorganization. No beginning, no end. And this brilliant sequence perfectly explains the expanding universe we observe today. We don't need a magical Big Bang explosion. Expansion just starts slowly, driven by the differences in informational entropy between the really dense regions and the empty ones. As the entropy tries to balance itself out, this expansion naturally accelerates until the difference peaks exactly at the 45-degree mark of the cycle. After that, it gradually decelerates until the universe becomes completely saturated with information at the 90-degree mark. This continuous flow completely eliminates any need for cosmic inflation. So what happens at the 90-degree mark? When the universe reaches that total informational saturation, it safely flips its polarity. It goes straight from matter to antimatter. Now, I know that might sound incredibly violent, but the author notes it doesn't break the fundamental laws of physics. It preserves symmetry through what's known as CPT invariance. That stands for charge, parity, and time. It basically means the basic properties of particles just flip cleanly, almost like looking in a mirror. It's not a destruction of the universe, it's just a seamless, coherent reorganization of the whole informational web. Which brings us to Section 4, Solving Cosmic Mysteries, or as it's called here, the mathematical patch. So this all sounds fascinating theoretically, right? But how does it actually hold up against real-world astronomical observations? Well, this direct comparison perfectly summarizes how the Big Circle elegantly answers the biggest mysteries of cosmology without having to invent arbitrary concepts like dark energy. Where the standard model requires an inexplicable point of infinite expansion, the Big Circle uses a smooth inversion point. Where the standard model invents repulsive dark energy to explain why expansion is speeding up, this model simply points to entropic difference and local time. And the universe temperature of the universe? The standard model patches that with superfast inflation, but here, it's easily explained by the global informational resonance left over from the previous cycle. It just clicks into place. Take the infamous Hubble tension, for example. Astronomers right now are completely baffled because measurements of the universe's expansion rate just don't match up depending on where we look. But in the T-squared model, this is naturally solved. Observers in relatively empty space literally measure time differently than those in dense, info-heavy environments. The expansion rate isn't some universal constant. It's completely local, modulated by data density. This also seamlessly explains one of the biggest headaches caused recently by the James Webb Space Telescope: why we keep finding fully mature, extremely old galaxies early in the universe, right where they supposedly shouldn't have had time to exist. According to the source, the slower local time rhythm in highly congested regions makes events within them appear to evolve much faster when observed from the outside, so they don't require some early anomalous formation period. It's actually just an optical illusion caused by informational time dilation. Crazy, right? Now, the most exciting part of any scientific theory is that it has to be testable. You can't just throw out ideas. The author explicitly points out that future deep space missions, like the Euclid telescope and JWST, could actually detect the specific informational deviations predicted by this model. They're looking for a tiny 1 to 2% variance in redshift and Hubble rate variations across different densities of space. If they find these specific variations, it could provide the hard, undeniable observational proof this theory absolutely needs. Ultimately, the author reminds us of the core philosophy driving this entire framework. The universe is not a trampoline fabric, bending and stretching to accommodate heavy objects. It doesn't adapt. It simply is. It's a singular, unbending informational web operating from the microscopic quantum scale all the way up to the infinite cosmos. Space is static. The only thing that actually changes is the data. I want to leave you with this highly provocative thought to end our explainer today. The mathematics of the Big Circle theory theoretically allow us to pinpoint exactly where we are on that 90-degree curve. So if we are just riding an informational entropy wave, and time is really just an illusion of data processing, how close are we to reaching full saturation? How close are we to the next massive cosmic flip into antimatter? It's an absolutely incredible shift in perspective, and for sure something that makes you look up at the night sky just a little bit differently. Thanks so much for joining me for this breakdown.
Subscribe for more